Welcome to Bedtime Astronomy. Explore the wonders of the cosmos with our soothing Bedtime Astronomy podcast. Each episode offers a gentle journey through the stars, planets, and beyond, perfect for unwinding after a long day. Let's travel through the mysteries of the universe as you drift off into a peaceful slumber under the night sky. This week in astronomy: DART mission, Adras mission and Europa Clipper update. Asteroid moon transformed. DART's impact rewrites Dimorphos' destiny. NASA's double asteroid redirection test, DART, mission has made a historic impact, literally and figuratively, by successfully altering the physical characteristics and orbital dynamics of the asteroid moonlet Dimorphos. This mission marked the first real-world demonstration of a kinetic impactor as a planetary defense method, aiming to protect Earth from potential asteroid threats in the future. On September 26, 2022, DART collided with Dimorphos, a small moonlet orbiting the larger asteroid Didymos, located about 11 million kilometers from Earth. The mission's objective was to see if a spacecraft could change an asteroid's course by smashing into it at high speed. The results exceeded expectations, with the collision not only altering Dimorphos' orbit but also significantly reshaping its surface. Dimorphos, prior to the impact, had an almost spherical shape with a relatively stable orbit around Didymos. However, the force of the DART spacecraft, which was traveling at approximately 6.6 kilometers per second, caused a massive release of material from the moonlet's surface, an event known as an ejecta plume. This plume consisted of rock, dust, and other debris that was violently expelled into space, significantly altering the moonlet's shape and surface composition. The most profound change observed was in the moonlet's orbit around Didymos. Before the collision, Dimorphos completed an orbit around Didymos every 11 hours and 55 minutes. The impact of DART shortened this orbital period by more than 30 minutes, a substantial alteration that far exceeded the mission's initial success criteria of a 73-second reduction. This marked the first time humanity has successfully changed the orbital period of a celestial body in space. The aftermath of the collision has provided scientists with a treasure trove of data. Detailed analysis of the impact's effects on Dimorphos' surface revealed that the collision caused widespread surface disruption, creating new craters and reshaping the moonlet into a more elongated form. The ejecta plume observed after the impact also provided critical information on the composition and internal structure of Dimorphos, offering insights into the behavior of such bodies in space. These findings have profound implications for planetary defense. The ability to alter the trajectory of an asteroid or moonlet opens up new possibilities for protecting Earth from potential impacts. The success of the DART mission demonstrates that kinetic impactors could be a viable method for deflecting hazardous asteroids, providing a potential safeguard against future threats. Moreover, the mission's success highlights the importance of international collaboration in space exploration and planetary defense. The DART mission was led by NASA, with significant contributions from the European Space Agency, ESA, and other international partners. The data collected from the mission will be shared globally, contributing to a collective effort to develop strategies for protecting our planet from cosmic hazards. In conclusion, NASA's DART mission has not only achieved its primary objective but has also set a new precedent in planetary defense. The successful alteration of Dimorphos' shape and orbit demonstrates the feasibility of using kinetic impactors to change the trajectory of celestial bodies, potentially safeguarding Earth from future asteroid threats. As scientists continue to analyze the wealth of data from the mission, the DART impact will likely influence future planetary defense strategies, ensuring that humanity is better prepared for the challenges of space. Adras mission, pioneering the future of space debris cleanup. Astroscale, a global leader in space debris removal, has recently taken a monumental step toward addressing the growing issue of space junk with its new contract awarded by the UK Space Agency. This contract paves the way for the development of the Adras mission, a groundbreaking project designed to tackle the ever-increasing challenge of managing orbital debris. Space debris, which consists of defunct satellites, spent rocket stages, and fragments from past collisions, represents a significant and escalating threat to the future of space exploration and satellite operations. As the number of satellites launched into orbit continues to rise, so too does the risk of collisions, which can produce thousands of additional fragments and exacerbate the problem. The Adras mission, named after the Greek word for invincible, is set to be a critical demonstration of Astroscale's capabilities in debris removal. The mission aims to capture and deorbit a specific piece of space junk, a task that requires precise navigation, advanced robotics, and innovative engineering. This will be one of the first times that such a complex operation is attempted, and its success could have far-reaching implications for the future of space sustainability. The need for effective space debris removal is more urgent than ever. The Earth's orbit is becoming increasingly congested, with thousands of active satellites and millions of pieces of debris. Even small fragments can cause significant damage to operational spacecraft, and the potential for catastrophic collisions is a growing concern. The problem is compounded by the fact that once debris is in orbit, it can remain there for decades, or even centuries, posing a long-term hazard. Astroscale's Adras mission is designed to address this challenge head-on. The mission will involve a specially designed spacecraft that will rendezvous with the target debris, capture it using a combination of robotic arms and other technologies, and then safely deorbit it. The spacecraft will be equipped with advanced sensors and autonomous navigation systems to precisely locate and approach the debris. Once captured, the debris will be either guided to burn up in the Earth's atmosphere or placed in a safe disposal orbit. This contract with the UK Space Agency represents a significant vote of confidence in Astroscale's approach to space debris removal. The UK has been increasingly active in promoting space sustainability, recognizing the critical importance of preserving the orbital environment for future generations. The Adras mission aligns with the UK's broader efforts to establish itself as a leader in space technology and sustainability. In addition to its technical challenges, the Adras mission also represents a significant logistical and regulatory milestone. The mission will require close coordination with international space agencies, satellite operators, and regulatory bodies to ensure that it is conducted safely and effectively. The success of the mission will not only demonstrate the feasibility of space debris removal but also set a precedent for future missions and international cooperation in this critical area. The implications of the Adras mission extend far beyond the immediate goal of removing a single piece of debris. If successful, the mission could pave the way for a new era of space operations, where active debris removal becomes a routine part of satellite management. This would help to mitigate the risks associated with the growing population of space junk and ensure the long-term sustainability of Earth's orbital environment. Astroscale's work on the Adras mission is part of a broader effort to develop a range of technologies and services for space debris removal. The company is also working on other projects, including the End-of-Life Services by Astroscale Demonstration (LCD) mission, which aims to demonstrate the capture and removal of multiple pieces of debris. These efforts are part of a growing recognition that space debris is a critical issue that must be addressed to ensure the future of space exploration and satellite operations. The success of the Adras mission could also have significant economic implications. The space industry is a rapidly growing sector, with satellite services and space exploration expected to play an increasingly important role in the global economy. However, the continued growth of the industry is threatened by the risks posed by space debris. Effective debris removal could help to protect valuable satellite infrastructure, reduce the risk of costly collisions, and enable the continued expansion of space activities. Furthermore, the Adras mission highlights the importance of international collaboration in addressing the challenges of space debris. Space is a global commons, and the problem of space debris cannot be solved by any one nation or company alone. The success of the mission will depend on the cooperation of multiple stakeholders, including space agencies, satellite operators, and international regulatory bodies. This collaboration will be essential to developing a coordinated and effective approach to space debris removal. Astroscale's contract with the UK Space Agency for the Adras mission is a landmark achievement in the field of space sustainability. The mission represents a bold and innovative approach to tackling one of the most pressing challenges facing the space industry today. By developing and demonstrating the capabilities needed to remove space debris, Astroscale is helping to ensure the long-term viability of space operations and the continued growth of the space economy. As the Adras mission progresses, it will likely attract significant attention from the global space community. The mission's success could inspire other countries and companies to invest in similar initiatives, accelerating the development of a robust and sustainable infrastructure for space debris removal. This, in turn, could lead to the establishment of new standards and best practices for satellite operations and debris management, helping to safeguard the orbital environment for future generations. In conclusion, the Adras mission represents a critical step forward in the effort to address the growing problem of space debris. Astroscale's innovative approach to debris removal, supported by the UK Space Agency, has the potential to transform the way we manage and protect Earth's orbital environment. The success of this mission could mark the beginning of a new era in space operations, where the responsible management of space debris becomes a fundamental part of our exploration and utilization of space. As we look to the future, the Adras mission stands as a testament to the importance of sustainability in space and the vital role that innovative technologies and international collaboration will play in achieving this goal. Europa Clipper's giant solar wings set for epic exploration of Jupiter's icy moon. NASA's Europa Clipper mission, slated to explore Jupiter's icy moon Europa, has reached a significant milestone with the installation of its supersized solar arrays. These arrays, built by Airbus, are each 30 feet long and represent the largest solar panels ever attached to a NASA planetary spacecraft. The size of these arrays is crucial for the mission, as they will provide the necessary power to operate the spacecraft's instruments during its journey and exploration of Europa. Europa Clipper's mission is one of great scientific importance. Europa, with its icy surface and potential subsurface ocean, is considered one of the most promising places in our solar system to search for signs of life. The spacecraft is equipped with a sophisticated suite of instruments designed to study Europa's ice shell, surface composition, and potential plumes of water vapor. The data collected by Europa Clipper will help scientists better understand the Moon's geology and assess its habitability. The solar arrays are a key component of the mission's success. Unlike missions to the inner solar system, where sunlight is more intense, Europa Clipper will operate far from the Sun, where light levels are much lower. The large surface area of the solar panels is necessary to capture enough sunlight to power the spacecraft and its scientific instruments. When fully deployed, the solar arrays will stretch out to 100 feet from tip to tip, making Europa Clipper one of the most distinctive spacecraft ever built. The development and testing of the solar arrays involve the collaboration between NASA and Airbus, leveraging advanced engineering to ensure they can withstand the harsh conditions of space travel and the unique environment around Jupiter. The arrays were subjected to rigorous testing, including vibration, thermal, and vacuum tests, to simulate the conditions they will face during launch and operation. Their successful installation marks a critical step forward in the spacecraft's assembly and preparation for its mission. The Europa Clipper mission is scheduled to launch in October 2024 aboard a SpaceX Falcon Heavy rocket. Once it arrives at Jupiter in 2030, the spacecraft will enter orbit around the giant planet and begin a series of flybys of Europa. These flybys will bring Europa Clipper within 16 miles of the Moon's surface, allowing it to gather high-resolution data and provide unprecedented insights into this enigmatic world. This mission builds on decades of research and exploration, including observations from the Galileo spacecraft and the Hubble Space Telescope, both of which provided tantalizing hints about Europa's potential to harbor life. Europa Clipper's findings could have profound implications for our understanding of the conditions necessary for life and the possibility of life beyond Earth. As the spacecraft moves closer to its launch date, the installation of the solar arrays marks the culmination of years of planning, design, and testing. With these arrays in place, Europa Clipper is well on its way to becoming one of the most ambitious and scientifically significant missions in NASA's history. The spacecraft's journey to Jupiter and its exploration of Europa will not only advance our knowledge of the solar system but also inspire future generations of scientists and engineers. The mission represents a new era of exploration, where advanced technology and international collaboration come together to push the boundaries of what is possible. As Europa Clipper prepares to embark on its journey, it stands as a testament to human curiosity and the relentless pursuit of knowledge, ready to uncover the secrets of one of the most intriguing worlds in our solar system.